A few quick notes on this video. This is an older video that I put together on a Philco 16M91, I believe it was. It's a fairly common Philco chassis that is basically a clone of an RCA CTC 15 that Philco made. There's a few little modifications on it. But this was a video where I was troubleshooting a focus problem, and in the video, at the end of the video, I used, I don't know if you can see this, I used my DVD player with an episode of The Simpsons to display how well the TV was working with the bright colors and that. And there was no audio at all. It was simply just background with me talking. And YouTube actually picked up the video that was on this old round tube TV with the horrible cataract and labeled and blocked the video and gave me a copyright strike for it, and actually identified the episode. And I had this video super compressed, very low quality, and again, it's a video of a TV, an old 60s TV with The Simpsons playing on it, and YouTube was able to identify it and block the video and strike me for it. This is copyright stuff's getting pretty out of control. I didn't feel like I was infringing on, anything. It wasn't any kind of content that would have jeopardized Fox broadcasting in any way. So, some more notes on this TV. I haven't really worked on it anymore since, and there you can see just a second of that.
Here's what it looks like. Really pretty. Finally got the horizontal.
So I'm gonna put this video back together and cut these ending pieces off, so you won't get to see the whole video. But basically, on this set, as I ran it, more and more of the red drop capacitors would drift. Every time I turned it on, it would lose color sync, it would lose something. So I basically just mothballed this project because this set really needs all the capacitors changed. And usually that's kind of rare for a 60 set, where just some of the electrolytics will fail. But this had bad disc caps, and the orange and red drops. This thing just needs a complete total recap, like an old 40s, 50s TV or radio would need. So anyway, sorry for the rant, and enjoy this video and take what you can get from it. Here we have a 1966 Philco all-tube color round CRT set. Chassis number is 16M91, and the CRT test's excellent in this, but there's a bit of a focus problem. Turn that off. So the first thing we need to do is take a look and see why there's no focus, why it's so far out. Taking a look at the focus voltage here, it is very low. I have 2 meters. I have a Simpson 260 that goes up to 5,000 volts, and also my CRT tester has a 10 kilovolt probe, and you can add this guy onto it here, which increases it by to 50 kilovolts to check the high voltage. And I don't really trust these, so I always like to use 2 meters to check. And we're actually getting about the same on these. This one's showing about 1,700 and this one's showing about 1,600, and the focus voltage should be about 5,000, around 5,000. And this is the focus adjustment, and turning this has absolutely no effect whatsoever on the voltage. I can turn it all the way from in to out, and it does not change 1 volt. So there's definitely a problem there. This uses a focus coil. Take a look and see if this thing will focus in on the schematic here. So this uses a solid state focus rectifier, and it comes and it goes up to the CRT, and then it comes down through this 150 picofarad 6 kilovolt capacitor to the focus coil. And since the focus coil is having no effect at all on this voltage, I'm going to take a look at this capacitor right here. Maybe it's completely open or shorted or something. Take a look inside here. All the parts are mounted on this side of the flyback board here. It's kind of tough to work on. I'm probably going to have to pull the entire high voltage cage off the chassis to get in there. Get in here a little bit better. It's kind of interesting is the flyback appears new in this set, or relatively low hour. You can tell by how supple this rubber is. It's very soft, and the high voltage lead here is very soft and not brittle. I do have 2 extra chassis I picked up with this set, and this would be an example of a more used flyback. This thing is hard as a rock, and this wire is brittle. If you were to bend it, it would practically snap. You can kind of see a little bit of wax dripping for this. Also, I would note that if we take a look at this one, back behind it, it's really hard to get in here with the camera. There's a ton of wax back in the back of the can here. I don't know if this is, yeah, it's all loose. This could be from a previous flyback that melted down, but there's a ton of wax, just loose wax rolling around in the back of this. So a little bit further investigation is needed here. Upon a close visual inspection of the capacitor that I suspected could be bad, I found that one of the leads is broken off. It's not even connected. I don't know if you can see this in the camera here, but this is the capacitor right here. And like I said, the location is not the best to try and film something, but I don't know if you can see that lead right there. So this capacitor is just kind of hanging on here by one lead. And that would explain a lot of the problems. It's always really important when you're working on an old set like this to just take a time out and visually inspect everything in the area of the trouble, and it can save you a whole lot of time in the end. Let me, well, that capacitor's disconnected. That's a convenient time to check it, so I'm going to take a quick test of it. I got my cap tester clipped on that 150 picofarad capacitor, and interesting, it is dead or open or something. I do not get the eye to open in any range anywhere. This is really the only type of capacitor tester that's halfway decent at checking these capacitors. And you can put this on a leakage test here, and the eye will open, and this is the leakage voltage, and this one goes up to 500. You can turn this up, and if there was any leakage, the eye would close and stay closed. It wouldn't stay open. So this capacitor is checking completely bad, which is interesting because I inspected the broken wire with a magnifying glass, and it looks like it was a vibration type failure, or broken, not left unsoldered when the flyback was replaced or something like that. It looks like a physical kind of mechanical break, but it definitely checks bad. So let me look a little further into this. I lifted the high voltage shield can up here so I can access the capacitor that had the broken lead and checked bad, and it does in fact check bad. I wanted to make sure I could get good contact on both leads, good access to it, and this is one of those lessons that parts that generally never go bad do go bad. So on these disc caps, don't say, oh, that's not the problem because it's a disc cap, when in fact here's proof that these things go bad. So I need to try and find a 150 picofarad at 6 kilovolts. Actually, this one looks like it says 130 plus or minus 20%, but a 150 would work. I'll have to see what I can scrounge in the parts bin. Here I have a Packard Bell parts chassis that was out of a new old stock set, and I've been working on parting this thing out, and this has basically the same focus circuit. Most color sets of this vintage that use a focus coil use basically the same parts, either the focus rectifier, tube, or solid state, a couple resistors, and this capacitor here happens to be green, and this one's made by TDK, and it's 130 picofarads at 6 kilovolts in 2200. I'm going to pull it loose and check it with the tester and see what it looks like. So I have the replacement TDK 130 picofarad capacitor hooked up to the cap tester here, and you can see we get a definite eye right there, definite eye opening right at 130 picofarads, so that looks really good. I have the capacitor right here on the unit itself without the test leads. That's the best way to check these small values. Go ahead and install it and see if it makes any difference. Well, what a difference that made. We're up to about 4.5 kilovolts on the focus pin on the CRT, and turning the focus coil now does adjust the focus, and this is pretty good right here. The blurriness around the edges is the cataract from the delamination of the safety glass. I will deal with that later after I get this thing working decently. So the next thing to do is to put a signal generator on it and take a look and see what it looks like. Well, it's receiving the signal, but it looks like it has some horizontal frequency issues. The horizontal hold is all the way at one end of its travel, and this is the closest I can get. If I go the other direction, the picture just gets dimmer and high voltage drops off. So the next thing to do is to check into why the horizontal frequency is so far off. Finally got the horizontal to lock in after kind of tweaking this coil beyond what it should be. You can see I got the core backed out about 3/4 of an inch out of the form there, but I did get the set to lock in. And here's what it looks like. Really pretty crappy overall. It could be a lot better, but a lot of this could be that I'm using an old B&K 1077 television analyst, and it's not really very good. I do have an NTSC generator, which when the rain stops, I'll bring that over here and see what it. So you can see the cataract there on the side really almost looks like mold. Really kind of makes the picture blur out, so that's going to have to be removed. But we do have color, we do have a fairly good picture. All the controls need to be cleaned and serviced, and it needs to be found out why the horizontal is so far out that adjustment has to be so radically out of place to get it to lock.